Welcome back. In this task, we will look at the hypothesis tests on discrete x and continuous y. After performing the stability, shape, and spread tests as in the previous tasks, we move on to actually performing the hypothesis testing using one sample t-test, two sample t-test, ANOVA, uh, and non-parametric tests such as Wilcoxon, Moods median, and Kruskal. We're going to import the same data that we did in the previous task and assign the price data for age equal to pre-owned and age equal to new build into Y1 and Y2. So let me select these three lines of code and run it, and Y1 and Y2 are created. We can perform hypothesis testing for single samples, two samples, and more than two samples, 3 plus. So let's do the single sample testing. We use one sample t-test for the purpose. Now, before I explain the null hypothesis and p-value, etc., we actually run the test because it will illustrate us the concepts. Let us run the mean for y1 first of all. So what is y1? Y1 here is the price value for age equal to pre-owned. So it's the average price for all the pre-owned properties is 437,599 that we calculated. However, let me run this test, t-test of y1 with mu, that is mean equal to 450,000. So I'm assuming a mean of 450,000 and checking whether that is correct. And when I run it, I get these results. And here we see this 95% confidence interval, which means the mean really is in between these two values, 381,000 and 493,000. Now, obviously, 450,000 lies between these two values. Therefore, we get a p-value of 0.6, meaning our hypothesis that the mean is 450,000 is true because that value 450,000 falls within the statistical range for the mean. So let's go back. What's the null hypothesis? The null hypothesis is that the reference mean is within the range of statistically estimated mean. An alternative hypothesis is the reference mean is actually not within the range but outside the range. And therefore, when p-value is less than 0.05, we reject the null hypothesis. But here, in our case, it is not less than 0.05. Therefore, we keep the null hypothesis. And the null hypothesis is that the mean is 450,000. So 450,000 falls within the statistical range for mean for y1, and that's the conclusion for this hypothesis. Now, what if the y1 data is not normal? So let's check the normality of y1 using Anderson-Darling test, which we have performed previously. So let's run it, and we see the p-value is less than 0.05. And so our null hypothesis is that the distribution is normal, but since p-value is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis, which is that the distribution is not normal, is non-normal. And therefore, we have to do a different test rather than one sample t-test. Here, we will perform a Wilcoxon test, which is also known as Mann and Whitney test, Mann-Whitney test, or also known as Wilcoxon rank sum. Okay, so let's check what the median of y1 is. Median is the center value of the data, so 377,500. Now we want to check whether 380,000 can be the median of this data, because remember, like mean, median also has these 95% intervals. Statistically speaking, it is not a single value, it is a range. And therefore, we will check whether 380,000 as a price could be within the range of the median. So let's check it and ignore the red warnings here. It doesn't matter. And we see a p-value of 0.2, which means that we don't reject the null hypothesis. We keep the null hypothesis. And the null hypothesis is that 380,000 is indeed the median. So that's the conclusion for Mann and Whitney test or Wilcoxon rank sum test for one sample. Let's now look at two samples. We want to compare two samples using a two-sample t-test or Wilcoxon test, depending on whether or not the data is normal. Now, the null hypothesis for this kind of a test is the means of these two groups are statistically the same or equal. An alternative hypothesis is that the means of these two groups are statistically not equal. And therefore, when p-value is less than 0.05, we reject the null hypothesis. Now, when the data is normal, meaning both the y1 and y2 are normal and they have equal variances, we use two sample t-test. Okay. And when the data is normal and for unequal variances, even then we use two sample t-test. But we apply a flag on the two sample t-test where we say var.equal to false. So this option we add for the two sample t-test when the variances are unequal. Okay. But still the data is normal. When the data is not normal, then we use Wilcoxon rank sum for when the data points are less than 20. But if the data points are greater than 20, we can still use two sample t-test. But we need to obviously apply variance equal is equal to true or false depending upon the case for non-normal. These are the rules to apply for two samples. So let's perform the two sample t-test. Let's first calculate the average values of y1 and y2 using these two commands, mean of y1, mean of y2, and we get these two values. So for pre-owned, the average value or average price is 437,599, and for new build, it is 546,000. Okay, so let's do the t-test. For y1 and y2, we put variance equal to true, right? And let's choose this one and run it, and we get the result. We get the p-value here. It shows less than 0.05, which means that the average of y1 and y2 are not equal. There is another way we can conduct this test without having to extract the data into y1 and y2. We can directly use our table dt and use this $ and price, which means this is the price column of the data table. And this symbol, use this symbol and do the age. So basically we're checking price versus age. You have got, if your data is in this form, you could use it too. And when we run this, we get pretty much the same results. In fact, there's absolutely no difference. This is what we get. Now let's check the normality of y1 and y2. I think we've done this in the previous task, but anyway, let's see. The p-values are very close to 0, and so they are not normal. Now, we want to use our algorithm that we have mentioned above here. So it is not normal, and so we want to check whether these samples are less than 20 or greater than 20, right? If you want to check the number of samples, you can use the length of that column of y1 and y2, and so that gives you the data. So there are 46 houses sold in pre-owned category and 89 new build category. So you will know how many houses, how many data points. Since the data points are greater than 20, right, we don't have to use Wilcoxon rank sum. We can use two sample t-test again, and depending on the variance, whether it's equal or unequal, we can use this true or false option. Since we've already tested this t-test, right, with variance equal to true, let us just try with variance equal to false, just for the sake of it, and see what happens. And here again, the p-value is less than 0.05. Therefore, the medians in this, the means in this case are different. We use the t-test, and it's the same conclusion whether or not the data is non-normal. But of course, for non-normal data, we can also compare the medians. Now let me do this box plot for price by age. dt is the data. You will see how the data looks. And this is the new build and the pre-owned. You can use the box plot command. This is the price. And this thick dark line is the median. right? We're questioning whether now the medians are equal or not. So let's look at the medians of y1 and y2, and we get about 377,500, and the other is 500,000. Okay, so now let's perform the Wilcoxon test for y1 and y2 and check whether the medians are equal. And we get a p-value very close to 0. So our conclusion is that the medians are not equal. We have another test known as Mood's median test. It's almost similar. Just let's select it for y1 and y2. And again, the p-value is 0.0023, which is a lot less than 0.05. Therefore, we reject the null hypothesis and accept the alternative hypothesis, which is the y1 and y2 samples have totally different medians. So we come to that conclusion in both cases. Now let's talk about three sample scenario. So far we had this y1 and y2 data. So y1 is pre-built and y2 is new build, and so we have two samples, but sometimes you may have three samples or more, in which case we use ANOVA and Kruskal values. And the null hypothesis means that the means of three or more groups are statistically equal. And the alternative hypothesis is that the mean of these three or more groups, they're not equal statistically. And when p-value is less than 0.05, therefore we reject the null hypothesis. It's the usual method. Now, let's do this. We have to now use a different thing for the three groups, because we have only two groups in the age category, but we will use a property type category. So if I, like for example, issue this command, this is the number of properties, an average price by property. This is what we do. Let me run it. You will see what it means. So we have property type, flat, semi-detached, terraced, other, and 95, 5, 28, 7, and these are the average prices. Okay. Now we can do a box plot of them. Again, dt is the table, price and property type are the column names. When you run it, you get the box plot of the property type, flat, other, terraced, and the semi-detached. It didn't have space to display here. If I had actually zoomed in, yeah, you see here flat, other, semi-detached, terraced. I zoomed it, cut it off. So all these thick lines, the dark lines, are the median values. So now we can visually inspect and come to a conclusion. But if you want a p-value, then you have to do ANOVA. So you just run this line of command called summary AOV is analysis of variance. And here dt price is the price column by the property type. So basically we are performing analysis of variance of price by property. So the discrete category variables are on the second option here, and the first one is the continuous. Okay, so let's run this command and we get the p-value. The p-value is 0.08, which means we cannot reject the null hypothesis. They're all equal, it says, and the reason why they're equal is because except for not all of them are equal, to be honest. I mean, they're all clubbed up together. Let's do the Kruskal values test, which in case if it is normal, if it is non-normal, we can do Kruskal values, and let's run it. And the p-value is again on the borderline 0.06, so we can't really distinguish them. But if we remove the flat and terraced, then you can see there is a difference between the other and the semi-detached. So we can actually selectively remove some of these and test separately. But when we have tested them all together, there seems to be no difference. And so really, when there are three or more samples, perform ANOVA, or to compare the medians, perform Kruskal values. Forget about the the variance and all that stuff. Okay, so you don't need those things here in three or more samples. Now here is the exercise for you. Perform ANOVA and Kruskal values tests for y equal to price and x equal to duration. Previously, we did for property type, but for duration. Although, just remember, duration has only two groups, but you can still do ANOVA and critical values for two groups. Although they are meant for 3+ groups, you can still do for two groups. So ignore it and do this exercise. Pause the video and don't forget to load the data. Pause the video, do the exercise, and come back, and I will discuss it with you. Welcome back. Trust you've been able to do it. Let's first get the data, dt, right? And all I need to do is, here in this case, I type duration and run this for ANOVA. And I get a p-value of 0.3. So there is no difference between the duration type um, in the duration type. So let's do the box plot as well. Actually, here if I do the duration, so here freehold and leasehold, it's not much of a difference. Well, these two, the thick lines are the medians, and the yellow boxes show the 25th and the 75th percentile. And let's do the critical values again for duration. Critical values also gives 0.29, which means we cannot reject the null hypothesis. That means that the medians are equal in both the cases. We have now come to the end of this guided project, and I thank you for your patience for going through all these exercises, and I trust they will be useful for you in your career, and I wish you all the best. Thank you.